Welcome to NextLab's Expert Q&A series. This series was designed to inform you of relevant cybersecurity topics via expert knowledge.
Welcome back to the NextLab's Cybersecurity Expert Series. On this episode, we have our guest Emre Köksal joining us to discuss Zero Trust on the file level. Emre is the founder at Anchor, as well as a professor of electrical and computer engineering at Ohio State University. First, Emre will introduce himself, and then we will move into the questions.
Hello, my name is Emre Köksal. I'm the founder and CEO of Anchor. I got a PhD from MIT in electrical engineering and computer science. I'm also a professor of electrical and computer engineering at the Ohio State University. Today I'm going to talk about this concept of zero trust down to a file.
Thank you for your introduction, Emre. Now let's move into question 1. What does it mean to have zero trust on the file level?
Traditional IT controls focused on building perimeters around the data and the IT infrastructure. So the action space of these controls included locking down networks, devices, and people. But they have failed to protect data in major ways. The main reason for the failure is that these controls get in the way and frustrate business users to the point that they intentionally work around them. So as a result, the business users force IT to dial back the protection, resulting in nothing more than a security theater. So zero trust is the new philosophy in response to the shortcomings of the traditional approaches. The zero trust paradigm removes the notion of perimeter to protect the data or the infrastructure. Zero trust assumes any request to access the data or the network is not trusted, regardless of where it's originated from, and verifies the legitimacy of this request before granting access. So the idea here is that the request might be generated by an attacker who made their way inside the traditional perimeter. And even in that case, you need to protect your infrastructure. If you look at the earlier approaches to zero trust, they were based on this motivation. These early architectures were constructed around network or application controls. Namely, the assumption was that the attacker successfully breached your network and they're also capable of creating processes from your applications. And even in that case, you should be able to protect your data that's within the network and accessed by your applications from the successful attacker. So the new approach in zero trust is taking this one step further. Today, I'm going to talk about this new approach. It starts by asking the question, since the ultimate goal is to protect data, which is your most valuable asset, why don't you focus on this data directly, right? Why focus on protecting other assets around your data, all in the name of protecting your data? In zero trust down to a file, the protection is baked directly into the data. Namely, even when your data is accessed, shared, or even stolen, it remains secure. Simply put, wherever the data goes, even outside of the scope of its owner, the data owner, the data is protected.
Great insights on what it means to have zero trust on the file level. Now our second question, why do we need to extend zero trust down to the data and file level?
As I mentioned, the early zero trust architectures implement the foundational idea of removing the perimeter, right? But they are geared toward controlling the activity around data by integrating zero trust to infrastructure access controls and applications. So along this effort, these early approaches have taken several existing techniques in identity and access management, IDAM, authentication, and authorization. Much of these techniques are not completely novel. They don't need to be, because the way these techniques are utilized are different in zero trust. Now, there are two potential shortcomings of having zero trust at a layer above data, as in the aforementioned techniques. First, they do not eliminate data losses when data is taken away or stolen. So once access is granted to the data, the ownership of data is also passed on. For example, an insider with validated credentials at the time of access can still exfiltrate data. To that end, the main promise of zero trust is broken. because at that point you need to trust that user to keep the data safe, and trust doesn't scale. Let's understand this. Access is temporary, and that's how you want it. However, ownership is permanent. So when access equates ownership, an organization loses data when an employee leaves, when their data is stolen, when the data is shared with the partners, and so on. Second, these architectures still build protection based on the activity around data. In that sense, they show similarities to the old paradigm, despite removing this notion of perimeter. But the problem is the attack surface. The overall potential user activities encompassing IDEM, application behavior, system controls, make the overall security architecture extremely complex. And in any engineering system, including security, lack of simplicity almost always leads to lack of robustness. If a single component in a complex system is not properly calibrated, the whole solution potentially breaks.
Thanks, Emre. Let's move into question 3. How does Zero Trust at the file level strengthen data security?
Zero Trust push-to-file integrates security in a way that the data protects itself. In a sense, data becomes its own security boundary encapsulated in the file. Once it happens, it frees the user up as protection and control travels with the data. Wherever data goes, it's protected, and hence the perimeter is eliminated. Not only that, you can give access to data and collaborate without imposing any change in the applications you use or the way you store or share data. So with this data-centric approach to Zero Trust, you don't add friction to business or change any workflow. You align security with the business, not the other way around. To emphasize the point, once a file is self-protected, the protection is universal across all applications, networks, cloud and IoT platforms. So the attack surface becomes a single file independently of the applications or your platform. The economics of the attack also changes. The attackers need to work on each file separately, so the resources an attacker needs scales with the number of files. This is in contrast to a non-data-centric approach, where a successful exploitation of a vulnerability may lead to all files being exfiltrated. Furthermore, for an efficient security architecture, it makes sense to start your design with the data itself. Once the controls on the data are covered, all other controls become much simpler. Ultimately, you address the problem at the source, since much of the security is dedicated to protect the data in the first place.
Great points, Emre. Thank you for the insight. Now for our final question. What is your advice to those who are looking to implement Zero Trust at the data level?
Most organizations are hybrid, with sensitive information in the form of any file type, such as source code, corporate documents, and intellectual property like CAD designs, right? CAD drawings. So Zero Trust down to a file has to provide universal integration with all applications and all platforms, including cloud stores, servers, desktops, removable drives, and wherever information is stored in a fully transparent fashion. The solution must have a negligible performance impact in access delay. It should not require the users to change existing IT controls or how users and applications work every day. Further, all organizations collaborate with their partners, which is typically outside of the scope of the organization. As the files travel, control should extend transparently to the ecosystem of the partners as well. If a third-party vendor is accessing or being used, the solution must guarantee that the information is distributed over a zero-knowledge foundation with respect to each entity involved in storage and sharing or data processing. All of the above requirements necessitate a very careful system design and architecture. Such a design will involve integration across multiple layers of defense in depth for data security. So building a robust and highly performing system subject to all these constraints is a challenge, but it's not impossible.
Thank you so much, Emre. We truly appreciate your insights today. Stay tuned for the next episode of the Next Lab's Cybersecurity Expert Series, where we will discuss from access-centric to data-centric security with Maria Teguero. Thank you.